Welcome back. Okay, let's take example 2 of the half redox equation reaction. Now this is a normal chlorine atom reacting with what? With bromine. That gives us what? 2 chlorine atom and what? A normal bromine what? Atom. Now this is combination of both reduction and oxidation what? Process. We want to split it into their different half equation. So here, from 2E minus to Br2 is called what? Oxidation. How do we know? Here, bromine is -1. So from -1 to 0, the normal bromine here is 0 because it carries no charge. So from -1 to 0, here is what we call what? Oxidation. There's a loss of electrons there. Now, how do we balance it? If I add these 2 minus at the reactants, I will have a total of what? Of 4 electrons at the reactants, still having 0 charge at my what? At my right hand side. So what do? I'm trying to make sure that both sides are balanced. So this is 2 minus 2 times -1 is -2. So here what is 0? So 0 plus 2 times -1 is -2. So here we have -2 at the reactant, then -2 are what? Are the products. So we have balanced what? Our oxidation what? Half equation at our right hand side. Now I'm coming to the reduction half equation. This is a neutral chlorine atom with a 0 charge. Okay, giving rise to what? Chloride ion with -1 charge. So now from 0 to -1 is what? It means there is an increase in what? In electron. So this process is called what? Reduction. How are we going to balance it? Look for a side. When you add -2 to it, you equate it. So here we have 0 plus -2, which is what? -2. So we still have what? -2 at our right hand side. So here we have -2, -2. So we have balanced this equation. We break it down to their half equation and do what? And balance each of them, both of the oxidation half and reduction half. Okay. Balancing redox equation, the overall redox equation. Now this will take us what? A process. The question might come like this: determine the values of P, Q, and R. Where are the P? We have P, Q, and what? And R. P, Q, and R. How am I going to get my P? How am I going to get my P? In this case, we balance oxygen using what? Molecules of water. Balancing redox what? Equation. Determine the values of P, Q, and R. Now let me show you the full method of balancing this equation. We have Cr2O4 2 minus down to 2Cr3 plus. Now this process is what? Is reduction process, because chromium here is +6, while chromium here is what? Is +3. So how do we balance it? We do what? We add, how many atoms of oxygen do we have here? We have 7. So how do we balance oxygen in the redox equation? We use what? The same molecules of what? Of water at what? At our products. So in this case, we have 7 atoms of what? Oxygen. So plus what? Plus 7 atoms of what? Of water. By so doing, we have balanced what? Oxygen at our products right hand side. By so doing also, we have increased what? We have introduced another element called what? Hydrogen here. Okay? Hydrogen is introduced. How are we going to balance hydrogen? We copy the equation again. 2Cr2O7 arrow 2Cr3 plus 7H2. Now, we have 7 times 2 multiply out 2 atoms of what? Of hydrogen times the volume. So 7 times 2 is what? Is 14. So we introduce what? Plus 14 hydrogen what? Ion. Okay, so now we have balanced what? We have balanced both the oxygen and what? And the hydrogen. If you count, oxygen here is 7. Oxygen is how many? 7 times 1 is 7. Okay, we have introduced what? Hydrogen. 7 times 2 is what? 14. So we use what? Hydrogen ion to balance what? The hydrogen here. Okay, so now let's look for how we can balance what? The charge. Are we together? So bring out the equation again for the last time. Cl2O7 2 minus plus 14H plus 2Cl3 plus 7H2. Okay, so what is the total number of charge in the reactant? So how do we get this? I've taught us before how to do what? Calculate oxidation number of a compound. So let me quickly show you how we get this. So this is 2 atoms of what? 2 atoms of chromium. So you have 2 into oxidation number of what? Chromium plus what? 7, Abi? 7 in times what? Oxidation number of oxygen equals to what? Minus 2 because of this charge. So okay, we are looking for chromium. So 2 times chromium is equals to 2R plus 7 times what? Minus 2. What is minus 2? Minus 2 is what? Is the charge of what? Oxygen. Equals to what? Minus 2 as the charge. Is that okay? So we have here 2Cl plus 7 times minus 2 equals to what? Minus 14 equals to minus 2. Minus 2. Okay, so let's get our R now. So 2Cl equals to, transfer 2 to this other side. So minus 2 plus, when minus crosses, becomes what? Becomes plus. So minus 2 plus 14 equals to what? Plus 12. Divide both sides by what? By 2. So 2 and 2 goes. 2 here we have what? Plus 6. So the charge of chromium equals to what? Plus 6. So the charge of chromium here is what? Is plus 6 from what I've illustrated on the board for you. Plus 6. Whereas we have how many here? We have plus 3 in what? In the products. So in this case now, we have plus 6 down to what? Plus 3. Okay. Please let me clean this so I can have more space. All right. So let's balance the what? Electrons now. What is the total number of charge present here? Minus 2 minus 2 plus 14 times 1 equals to plus 14. But here we have how many? 2 times 3 is what? Plus 6. Are we together? So minus 2 plus 14 equals to what? Equals minus 12. Here we still have plus 6. So where are we going to add our electron to balance what? Our total redox equation. So look for the way in which you have what? A lesser what? A more ions to subtract it from it. So you can get what? Here we have more electrons. Here we have what? Lesser electrons. We are looking for a way to do what? To make sure that we have both number of electrons at the right hand side and also what? At the right hand side. So if you add 6 electrons here, you're going to have equal number of electrons. So here we have plus 6E minus. If you count it again, here will now becomes minus 2 from here, plus 14 from here, plus 6 times 1 is equals to what? Minus 6. So minus 2 plus 14, this is plus 14 plus 12. Minus 2 plus 14 is plus 12. Therefore, plus 12 minus 6 equals to what? Plus 6. So now we have balanced our both oxygen, hydrogen, and the charges. Okay, so that is how we arrive at our P. If you look at the equation here, our P here is, they say determine the value of P, Q, and R. P, Q, and R. So we use what? Our oxygen here to get what? Our what? 7. So 7 is here. 7 times 2 balances oxygen. So to balance hydrogen, this 7 here times 2 give us this 14. Give us the 14 And also we have 6 electrons. Total number of charge here, as we see, minus 2 plus 14 minus 6 is equal to 6. So here we have plus 6. So if we put 6 here now, we have balanced what this redox equation. So this is a full version of balancing a redox what equation. In case you see this kind of question, this is how to do what, to go about it. Okay, let's take example 2. Example 2. All right. MnO4 plus XH plus YE minus arrow Mn2 plus ZH2O. Find X, Y, and what? And Z. It's the same process. Carry this 4, okay? Introduce to X or to Z. You have 4H2. So 4 balance what? Oxygen, which is 4 here. We have introduced what? 4. So 4 here times 2 give us a 8. That's why you have what? X as 8. We have total number of charge plus 2 in the product. So if we have minus 1 plus 8, minus 1 plus 8, that is what? That is minus 1 plus 8 is plus 7. But we are having plus 2. So if you subtract 5 from 7, what do you want to have? You have plus 2. That's why we have y equals to 5e what? Minus. Following the same step I've described on the board for you. So that is how to balance a redox what? Equation. Okay. Tests for oxidizing agents. So we have 3 ways of testing for what? Oxidizing agent. The first one is by what? Oxidizing agent liberates iodine from acidified potassium iodide solution, forming a brown solution that turns blue-black when starch is added. That is the first test. Second test by using what? Hydrogen sulfide, which will give us what? A yellow sulfur deposit due to what? Oxidation of the sulfide what? Ion. The last one is very simple. It returns the green solution of ion 2 to brown colored ion 3. So whenever you see any of this, that compound contains what we call the oxidizing agents. Okay, also, how do we test for what? Reducing agents. We also have 3 methods. First of all, reducing agent decolorizes acidified purple potassium tetraoxomanganate 7. Now, the color of this compound is purple. When you introduce this into what? A reducing agent, it will change to colorless. As I said, what? It decolorizes acidified purple. That's the first test. Second test, it will change. Either you call it yellow or what? Or orange. They're the same, depending on the test we are using. Some textbooks use orange, some use what? Yellow. They are all correct. So it will change the color of orange or yellow color of acidified potassium heptaoxodichromate 6 to green. So whenever that happens, that compound contains what? Oxidizing agents. Then lastly, it will also turn brown ion 3 to what? To brown ion 2. So any of these 3 shows that we have a compound that contains reducing agents. Okay, these are some few JAMB questions gotten from this topic. If you look at 219 Model 2, question 34, JAMB exams, the question was like this. The reaction 2H2S plus SO2 equals 2S plus 2H2O. That is hydrogen sulfide plus sulfur 4 oxide give us what? Sulfur and water. Now the question is, what is this reaction? A redox reaction in which H2S is the oxidant and SO2 is the reductant. A redox reaction in which SO2 is the oxidant and H2S is the reductant. Now, reductant means what? Oxidizing agents. Don't forget. Oxidants means what? Oxidizing agents, reducing what? Agents. No, not a redox reaction. This one is false because this one is out of it. It is a redox reaction. So you cancel C, not you cancel C. So the answer is between what? A and B. So how do we know the answer? Let's look for explanation. Now, in H2S, hydrogen sulfide have what? -2 for sulfur. Sulfur here is -2. So when it now changes to what? To S. Don't forget, S here is what? Is a neutral element with a 0 charge. So from -2 to 0 is what? Is oxidation, loss of electron. In this case now, here acts as what? As a reductant. Because this H2 causes what? Oxidation. All the way around, SO2 here is what? Is +4. S here is +4. Moving down to 0 to S is 0. So from +4 to 0 means what? It is what? It is a reduction process. So it gains electron. So what causes that is what is called the oxidant or oxidizing what? Agent. Generally, S2S is a better what? Reductant than what? Than SO2. Okay, let's check our example. If we check 219, question 25, from JAMB past question, you'll see that which of the following reactions is an oxidation process? Don't forget that oxidation means what? Loss of electron. So A, Cl to Cl minus, which is not. This is gain. From 0 to -1 is gain of electron. So A is out of it. Now from +1 to 0 is also what? A gain of electron. So B is out of it. So now from -2 to 0, this is it. From -2 towards 0, this place oxygen now loses 2 electrons and become what? 0. All right. So here is what? An oxidation process. 1 and 2 are reduction word process. So this one is totally out of it. 2019 question 40. Another question comes like this. Consider the equation below, which is this. The oxidation number of chromium changes from, very good. I will take you back to the board. Chromium. I just finished solving this a few minutes ago. Here was what? +6. Cr2O7 minus 2 will give us what? +6 as a charge. +6 as a charge. Then here is what? Is +3 already. So chromium here will move from where? From +6 to what? To +3. So the answer there is what? Is B. So 7 to 3 is off. C and D is off. This is the actual answer. Okay, explanation. The oxidation number of chromium in Cr2O7 is +6, while that of chromium alone is what? +3. So the changes is from where? It's from +6 to +3. Okay. Question 16 from 2019. If acidified potassium dichromate 6, which is K2Cl2O7, acts as oxidizing agent, color changes from, this is just a bonus question, what is the answer? From orange to what? To green. Yes. Some says yellow, some tell says yellow, but the actual color that is universally known is from orange. So B best describe what? The answer. 2018 question 11. The balanced ionic equation for the reaction between K2Cl2O7 and SO2 in an acid medium is, don't forget, an acid medium. So if you pass through this stage I'm showing you, you will notice that the answer they will give us D. So break this equation, break this into your various half equation. So from Cl2O7 2 minus to 2Cr is your reduction. You balance it accordingly. Then from SO2 to SO4 is your what? Oxidation. Balance it accordingly. When you have it, okay, you now do what? Balance everything together. This is question 1, question 2. Everything to one side, reactant to reactant, then product to product. When you have equate this to 6. So you multiply equation 2 by 3 to have 6, so you can cancel out both. When you are finished doing that, you want to have Cr2O7 minus 2, which is what? Which is option, yes, option D. Cr2O7 2 minus plus 3SO2 plus 2 plus give us 2Cr3 plus 3SO4 2 minus plus S2. When you have what? Undergo all the process, passing through what I've shown you earlier on. Okay, next one, 218 model 3 question 10. Consider the reaction 2Al plus 6 plus, arrow 2Al plus 3 plus 3H2. What is the total number of moles of electrons transferred from the aluminum atoms to hydrogen atom? This one is simple. Break the aluminum to a half equation. From 2Al to what? 2Al3 plus is oxidation. So you balance it accordingly. So if you multiply this out, 2 times 3 will give us what? Plus 6. So you need what? Total of 6 electrons to cancel the H plus. Okay, is here. We have, yes, 2Al. 2 times 3 is minus 6. Then 2 times 3 is plus 6. So this plus 6 and minus 6 will not give us 0. So at the end, you're going to have 0 aluminum, 0 what? Aluminum. Because this is 6, this is 6, and they cancel out. So the answer there is what? Is 6 electrons to be added to aluminum to balance that equation. Okay, 213, question 23. Zinc plus CuSO4 plus zinc arrow, zinc sulfate plus copper. The question is, in the reaction above, what is the oxidizing agent? Very simple. For zinc, this is 0. 0, neutral element is 0. This is zinc 2 oxide. Zinc 2 oxide for Zn to Zn2 plus. And this is zinc copper 2 oxide, copper 2 ion to copper. So from plus 2 to what? To 0. Okay? So from zinc to zinc 2 is oxidation. From copper to 0 is what? Reduction. So what gives rise to oxidation? The answer there is what? Is C. So C is what? Is an oxidizing agent that enables what? Reduction to take place. Next question. Question 22 in year 2013. In the reaction above, the substance that is being reduced is, now let's look at the explanation here. The substance that is being reduced is F2. How do we get F2? Now from F2, this is 0. The charge of F2 is 0. Here is minus 1. So from 0 to minus 1 is what? Is oxidation. Sorry, is reduction. It means that it gained electron. 0 to minus 1, reduction, gain of electron. So F2 here is reduced. All right? While SO2 what? Is oxidized. So the answer there is what? Is A. F2 is reduced. 220, question 20, model 2. Given this equation, you have to find y. What is y? In the equation above, y is very simple. Balance the y I just showed you. 4 from here, you get water. How do you balance hydrogen? 4 times 2, 8. So answer is what? Ha plus. So it's option C. So these are some of the questions that come out from this reaction, this topic called redox reaction. 2014 also question 23. The oxidizing agent in the reaction above is very simple. Answer is what? Is B. Okay, oxidizing agent. This is from here to here, then from here to here. So this to this is what? Is oxidation. This is, yes, this is reducing agents. So from here to here is what? Reduction. So this is what? Our oxidizing agents. So oxidizing agent here is water. The reason is that it loses oxygen to the what? To the reducing what? Agent, which is what? Carbon. There's some few questions under redox reaction. All right, so let's move to another confusion topic that students sometimes are confused, which is equilibrium in a reversible reaction. Now, what is reversible reaction? This is a kind of reaction that occurs in both directions. It proceeds in both, that is the forward and the backward reaction. If you look at this equation on the board, A plus B, now the arrow that goes to my product is called what? The forward reaction. Okay, A plus B give us C and D. So going this way, going to my right is called what? Forward reaction. Coming back to my left is called what? Backward reaction. So they occur in what? In opposite direction. All right, in both directions. The product can give us reactant. The same reactant can give us what? The products. That's what we call what? Reversible. So this sign stands for what? Reversibility. A reversible reaction is in dynamic equilibrium when both the forward and the backward reactions are occurring at the same rate, thereby producing no net charge in the concentrations of the reactant or products. Now, when we talk about dynamic equilibrium, there is no change in concentration, no change in pressure, no change in temperature. Everything are the same. Nothing is coming in, nothing is coming out. Net equilibrium is actually balanced. So at that time now, there is no effect from concentration, from catalyst, from pressure, and otherwise. Okay, equilibrium constants. This is an example of a redox reaction. In case you are asked to write equilibrium constants for this, so it is always the reactant, the product all over what the reactant. You use their volume or their moles as a superscript. Now this curly bracket stands for what? Concentration. Concentration of ammonia, which is what? My forward reaction, ammonia, all over what? The concentration of nitrogen times the what? Concentration of hydrogen. Then their moles happens to be what? Used as superscripts. So if these moles are not like this, you are not correct in your what? Writing equilibrium. And don't forget, this equation only applies to gaseous substances in a chemical reaction, not aqueous solution, not solid, not liquid, but mostly gaseous what? Substances. Okay, Le Chatelier's principle. This principle states that if an external constraint, such as change in temperature, pressure, or concentration, is imposed on the chemical system in equilibrium, the equilibrium will shift so as to annul or neutralize what? The constraints. So these are the factors, some temperature, pressure, and concentration that most times causes some changes in what? In an equilibrium system. And this was what this man, Le Chatelier's, was trying to prove. Now, these are the factors that affect equilibrium. First, effects of a change in temperature, effects of a change in pressure, effects of a change in concentration, effects of a change in the catalyst. Let's start from the first one, temperature. Now, follow this rule. These are the rules I'm going to give you now, both temperature, pressure, catalyst, and the rest. Okay, let's take a break. When we come back, we continue from here.